Before we move on to our application problem for the central limit theorem, I want to reiterate the qualifications or the stipulations to use the central limit theorem. So it says that we have to be taking sample sizes of at least 30. That's what our program is going to require us to check. Or it says the original distribution needs to be normal. That's kind of the way out of that. So what that's telling us is that if this original distribution was already normal, we may not need sample sizes of 25 or 30 in order to achieve the desired results down here of getting a normal curve so that we can use the normal calculator on it. When your original is already normal, this is going to turn out to mimic that without a whole lot of, or without a large sample size. It's when this is something else, when it is some skewed or some other type of distribution up here, that's when you need to absolutely make sure that your sample size is large enough, because this will mimic this up to a certain point. So this is going to mimic a normal curve no matter what. If I started off with something up here skewed, then this would mimic that unless I was taking good enough sample sizes, and then that's when the CLT kicks in and says this is eventually going to look normal no matter what. Okay, so just make sure whenever you're reading your questions, you're being very careful to check that sample size and also be reading to see what did the original population look like. If it already looked normal, you're golden. You don't have to worry about it. The CLT already will work. But when that original distribution is something else, then you really have to be concerned about hitting that sample size. So let's go ahead and look back at our note sheet. So here's our example. So suppose a person has 5,000 songs saved to their some song library on their computer or on their phone. The mean length of all of the songs is 243 seconds, which is just over 4 minutes. And the standard deviation of all of the songs is 93 seconds, which is about 1.5 minutes. The distribution of song lengths is right skewed. I'm drawn to that. And the person wants to create a 25 song playlist. Okay, so what we've got here is we have the original population, all of the songs is right skewed. So what we know as we work our way through this problem is that unless we hit that sample size, then our sampling distribution of mean song lengths is going to continue to be right skewed. Only if we hit that sample size criteria of at least 30 can we say, okay, the CLT now kicks in and we can assume that that sampling distribution is going to be normal, and then we could proceed using the normal curve in order to perform calculations. So if we don't hit that, we're just kind of stuck and we can't move on. But let's stick with the questions that were given so far. First, it just wants to know what is the population and what is the sample. So here, in this case, your population is all of the songs, the 5,000 songs. All of the songs on this phone or computer or wherever they're looking. And what's the sample? They're going to create this playlist. So this playlist is going to be this randomly selected group of songs. So it's the 25 song playlist. That's the sample they're creating. Then it says, is the value 243 seconds a parameter or a statistic, and explain? So we want to look at what does the 243 seconds go to? Does that go to a population? Does it describe the population, or does it describe the sample? The 243 seconds is the mean length of all of the songs. Hence, we know that it is a parameter. And for the explain, I'm going to say it's a number that describes the whole population. That's what a parameter is. So in this case, we happen to know this number. Okay, what should the person expect the average song length for his playlist to be? Okay, so whenever we're doing this, when you're taking samples, you expect the mean or average to be the same as the population. So we can expect the mean length of the songs on his playlist to also be 243. Not minutes, seconds. That's way too long. But now that we're working with a sample, we want to know what's the standard error for the mean song length of 25 randomly selected songs. Okay, so this is where that standard error formula comes into play, and that's where we take sigma, the standard deviation of the whole population, and divide by the square root of the sample size. So we take sigma in this case is 93. That's the standard deviation of all of the songs. And we divide that by the square root of the sample size, which is 25. So 93 over 5. And that divides out to approximately 18.6 seconds. What if they chose 100 songs on their playlist? What would the standard error be then? Well, it's the same formula. Standard error equals sigma over the square root of n. So still 93, but this time over the square root of 100. 93 divided by 10 is approximately 9.3 seconds. What we can see here is exactly what we should have expected from prior knowledge, which is that as we take larger samples, notice that that standard error is getting smaller and we're able to be more precise in our answers.